The next presenter. Mr. Hidenori Miyoshi joined Hitachi Solutions in 2003, and he has developed many enterprise systems using Ruby. And he's also a member of Japan OSS Promotion Forum. And in private life, he is an editor of Ruby's magazine. So today, he will be talking on the topic of mruby application development in embedded hardware module. So over to you, Mr. Miyoshi. Thank you for the kind introduction. So I'm from the Hitachi Solutions IT Technology Promotion Center. I'm Miyoshi. So as introduced, I would like to talk about the mruby application development in embedded hardware module. So this is the agenda for today's speech. So let me just briefly introduce myself and also the measures taken at Hitachi Solutions. So as introduced, I'm working at Hitachi Solutions, and my current responsibility is to establish or build various enterprise systems using Ruby. And as for the deliverables, at the Ruby World Conference or at Ruby Association, I have been sharing a lot of my examples. So let me just touch upon the recent two examples. So one is Katsubun Mail Security Enterprise Mail Platform. So inside this paperback, our pamphlet is inside the back. So this is the brochure or pamphlet. So for the feature, I do not have time to share that with you at this speech, but if you refer to the pamphlets, you will get to be able to understand the details. And also, I will talk about the there is a Ruby Association URL, which will talk about the benefits using this system. And also the work order request system, which were previously done by email or by verbal communication, but on the internet we created this system. So if you go to the case examples on Ruby internet, there are more details. And as introduced, I will also belong to the application division of Japan OSS Promotion Forum. And for some of the work that has been done, I have shared the examples at the Ruby World Conference. And today, I will talk about, like the last year, I would talk about a similar topic from last year. So let me talk about what I talked about last year and what I did this year. So last year, I talked about Raspberry Pi, the one that I'm holding in my hand, the green case. This is called Raspberry Pi, and there's a GPS sensor, and the temperature sensors are attached by USB. And mruby application works, and to visualize the data, it was a simple application. So Raspberry Pi, as Mr. Tanaka mentioned, mruby application, this is the best option to run mruby application. But actually, so the performance is very good. So since Linux works, so many tools or mruby gems also work. And by just connecting the USB, sensor can obtain values. So it's very simple. But some of the disadvantages is that the specification is too high. And also C Ruby runs, so it doesn't make much sense to use mruby. And a lot of currency is consumed, so it's not possible to operate it in 4 consecutive hours. So this year, we decided to use the less powerful hardware than Raspberry Pi and to do the similar things. So as Mr. Tanaka mentioned, memory is around 400 kilobytes. And for this year, as the hardware, as you can see in the photo, the red circled one, the ESP-W-Room32, this is the hardware that we prepared. And last year, we used the Raspberry Pi, and when we compare these two, memory and the consumption current are very different. So memory consumption current, as you can see, they're totally different. They're in the different units. But ESP-W-Room32, but it's not Linux. But so existing mruby gems cannot be compiled, or they do not even work. So now I would like to talk about the using this device, and this is how it is done. So first, run mruby application on ESP-W-Room32, and next acquire the sensor data, and then handled on mruby. So like the last year, temperature sensor and GPS sensors are used. So first one, running mruby application on ESP-W-Room32. So there's already existing project. This is called project mruby SP32. So by using this ESP-W-Room32, mruby can be run on that. And the principle is very simple. So compile mruby application and output that as a C language array. And that array, so in the C language source for ESP-W-Room32, then read it and then compile it. As a result, the execution file for ESP-W-Room32 will be created. So what I'd like you to pay attention to is that there is nothing done on mruby, just a simple usage of command. So it's very easy to upgrade the version for mruby. And this is the actual example. So if you would like to do an output of hello mruby world 100 times. So first, mrubc, the mruby compiler command should be conducted, and in C language array. So this is the source, and using this source code and using the compilation results and ESP-W-Room32 out, as you can see in the red. So by reading this and making the C compiler, and then hello my mruby world will be output for 100 times. So now we know that mruby works, so let's try to obtain the sensor data. So like last year, we would like to try it with a temperature sensor and GPS sensor. For the temperature sensor, this is actually smaller, as you can see in the red circle. Compared with the ESP-W-Room32, it's very small. So this is the sensor we used, the ADT7410. This is there is an interface for I2C, and doing the bit calculation, it is possible to acquire the Celsius data. So on Raspberry Pi, this is often conducted, but on ESP-W-Room32, it's only C language API is provided. So this time, I created the mruby gems. So I implemented only the part to acquire the data on I2C communication, and then implement the on the application side. So I wanted to touch upon this outline, but due to time constraint, I have to skip this. So on the I2C communication, it's in C language, and the function of C language and mruby methods are linked. And then mruby application, the mruby gems will be called upon, and for the sensor specific processing will be done by mruby, and then the Celsius temperature is obtained. So next is GPS sensor. GPS sensor is similar. So we use the GPS sensor made by Taiyo Yuden. By using this sensor, with the UART serial communication, it's possible to obtain GPS data, and the data is in NMEA 0183 format. And by editing this data, it would be possible to obtain latitude, longitude, and time and date data. On Raspberry Pi, it's very simple, but with ESPWM32, the performance is not so simple. Only the C application API is provided. So again, I created the mruby gems. So I implemented the part where the data is obtained with UART0 communication, and then the data is edited on mruby application. I will skip these. So we pay attention to memory and the area which is circled by dotted lines should be paid attention to as well, and link the C language function and the mruby methods, and then mruby application. This is very simple. So when you call this, now it is implemented. So these are masked because it was my home, so I did not want everyone to know where I live, so it is masked. But this is the result we get. So time and date is also included, not just the latitude and longitude, but it is not so easy to read this data. So NMEA method is used. So this is also Ruby gems, but time and date and latitude, longitude will be provided, and that's at the end of the day. This is the nicely laid out data. This is not my home, so no need to worry. So it's this is a quiz from me. Where do you think this is? So this is the summary. ESPWM32. We successfully run mruby application on ESPWM32, and by creating the necessary mruby gems, we were able to obtain the necessary data from the sensors. And I didn't have time to share the details, but when you want to create the mruby gems, I did a lot of research, and I found out some of the effective pointers. So doc directory in the mruby GitHub repository, and also how to do the CPI application. So I also made a reference to the how to create an extended library in Ruby, which is on the GitHub repository. And there's also a mruby gem template. So these are pretty instrumental in creating the mruby gems. So I mentioned the goal was to do the to achieve the similar levels last year, but we were not able to achieve that because of the encryption did not work. Because of the library shortage, compilation does not work. So we are currently investigating how we can solve this using the ESPWM32 functionality. And this time we checked C API and created the mruby gems for each, but it takes time. So for each hard work, there is some project going on to handle this. So it will be IoT framework Peloton. So I would like to consider utilizing this. Thank you for your attention.